So we're going to start on page 4 of our 8.1 notes. To recap, to decide if polygons are similar, these two things, you want to be thinking of them like a checklist. The corresponding angles need to be congruent. Corresponding means A and E correspond. They are marked congruent. B and F correspond. They are also marked congruent. G and C, they correspond and they're congruent. And then H and D correspond and they're both 90. So that's correct. And then the corresponding sides have to have the same scale factor. If so, what is the scale factor? So the scale factor is what we have to multiply from one side to get the length of the other side. This one's obviously easier to see, but you can write it like this. 2 times the scale factor will equal 4. So divide by 2, and obviously the scale factor is 2. So you need to check to make sure that all of the sides of this are just like that. The scale factor is 2. Meaning 6 times 2, does it give you 12? Yes, so that has the same scale factor. 3 and 6 is 3 times 2, 6. Yes, so that has the same scale factor. And the same thing with 5. 5 times 2, is it 10? Yes, so they all have the same scale factor. And if so, what is the scale factor? Normally I would tell you from where to where, but from A to B, let's just say it is 2. If it doesn't ever say like what from which shape to which shape, you can just assume we're reading left to right. So A to B, it'd be 2. The second portion is talking about a similarity statement. Okay, similarity statement is similar to a congruent statement. You used to see them all the time. Triangle ABC was congruent to triangle DEF. And the order of the letter matters, right? So angle A corresponded with D, angle B corresponded with E, and C corresponded with F. It is the same idea with similarity, except for the figures aren't congruent, they are similar. So you'll have a similar symbol like that and not a congruent symbol. So using the figure above, we have C listed first. So C corresponds with G in the other figure, so G would come first. And then you have B, which is here. B corresponds with F, so F would come second. Then you have A, and A corresponds with E, so E. And then last, we have D, which corresponds with H. So this would be a similarity statement. All right, let's talk about perimeter. Just as a recap of what in the world perimeter is, perimeter is the distance around a shape. So 2 plus 3 plus 4. 2 plus 3 is 5, plus 4 is 9. This would be 9 units. Okay, then that's for any shape. If it looked like this, you would add all the sides. 2 plus 4 plus 2 plus 4. 2 plus 4 is 6, plus 2 plus 4 is 12 units. Okay, and it could have as many sides, you would just add all the sides up and that would be the perimeter. So bring it back to this. This formula looks difficult and it looks scary, but I can guarantee you that it is not. So here's what you're going to write. You're not going to write what they have in the book. Here's what we're going to do for perimeter. So you're going to take the side from the first over the side from the second, and it will equal the perimeter of the first over the perimeter of the second. Because according to this, the perimeters are similar if the shapes are similar. So, the two gazebos shown are similar pentagons. Find the perimeter of gazebo A. So using this formula above, the only thing to know about these two sides is they have to be corresponding on the two figures. So when we go to plug in a side from the first figure, so aside from the first, you need to pick a side that the corresponding side on the other figure. So the only side we know in A is 10, and it corresponds with 15. So when we go to plug in our first side, it's going to be 10. Okay, it's from our first figure. And then we're going to plug in 15 from our second figure. And it will equal the perimeter of the first, but our whole goal here is to find the perimeter of the first. We don't know it. So we could just put P for perimeter. You could put X. It does not matter. And then over the perimeter of the second. So what you're going to have to do is add up all the sides of the second figure. So 15 plus 9 plus 12 plus 15 plus 18. Which is 69. So the perimeter of gazebo B is 69. We're going to find the perimeter of the smaller. So a way to check yourself, you got to make sure the top is from the same figure. So 10 comes from our first figure, and we don't know the perimeter of our first figure. And then the bottom, 15, comes from our second figure, and the perimeter comes from our second figure. So from here, we solve like normal. You cross multiply. 10 times 69 is 690. 15 times P is 15P. Get P by itself. It's being multiplied by 15, divided by 15. And the perimeter is 46, and it would be meters. Yes, you need to put the unit. It will be marked wrong. So that one's pretty simple enough. I'm going to show you some word problems that would appear possibly on an assignment. So this is a word problem. Two polygons are similar. The perimeter of one polygon and the ratio of the corresponding side lengths are given. Find the perimeter of the other polygon. So this one you can set up a proportion. Okay, so it's going to be the same thing that kind of the same thing that we just did. What we're going to do is set up a proportion where we set the scale factor equal to the side lengths. Okay, so we know whatever the perimeter of the second polygon is, it will be in proportion to the first, and that proportion is 3/4. So here's what we're going to do. Our proportion is going to look like this. So our fraction is 3/4. Okay, so we're going to set up a proportion where the smaller figure is on top and the bigger figure is on the bottom. And I'll show you why we do that. So the smaller figure is 12. We don't know the bigger figure. So P for perimeter, or X, however you want to do it. Once you've got this set up, we're going to cross multiply. 12 times 4 is 48. Okay, and then P times 3, 3P, divide by 3. And the perimeter of the larger object is 16, and it'd be 16 feet. Okay, 16 feet. How did we do that, Mrs. Marshall? Well, our scale factor is 3/4, right? Well, our two figures, their perimeter should be equal. The smaller to the larger should be equal to the scale factor of the smaller to the larger. So if we were to reduce this, they're both divisible by 4. Okay, so this one I just dropped down. But if we divide these two by 4, 12 divided by 4 is 3, and 16 divided by 4 is 4. Okay, so set up a proportion. The same thing on B. The larger polygon is 72 inches. Our scale factor is 6/5. So this one looks a little different because the bigger number is on top, which means our bigger perimeter should be on the top and the smaller should be on the bottom so that it stays proportional. So our bigger perimeter is 72. And the smaller is what we don't know, so we're going to call that P. Cross multiply. 72 times 5 is 360. P times 6 is 6p. Divide by 6, and the perimeter is 60, and then it would be inches. Okay, you can always check the scale factor from the bigger to the smaller, because the bigger number's on top, should be 72 over 60. It should reduce to 6 over 5, and here's how you do that. They're both divisible by 2. They're both divisible by 6. They're actually both divisible by 12. 72 divided by 12 is 6, and 60 divided by 12 is 5. So we did a good job. So that's the perimeter. We are halfway done. Now we talk about area. So area is very, very, very similar to perimeter, except for one thing. Remember that area is square units, and that will affect the formula. So it's similar formula. You're going to say side from the first over side from the second, and this is going to be squared, is equal to the area of the first over the area of the second. So the thing that students forget is that squared. So you got to make sure that you've got that going on. So we're going to fill this in. Aside from the first. So again, just like with perimeter, they have to be corresponding. Okay, it's pretty easy in these problems because it'll be the only sides that you have. So aside from the first would be 7. Aside from the second would be 21. We'll equal the area from the first. So the area is 84. We don't know the area of the second. So I'm going to put A for area. We are going to square these. So here's how you square a fraction. Squaring is multiplying times itself. So when you square a fraction, square the top. 7 times 7 is 49. And square the bottom. 21 times 21 is 441. So 49 over 441. Or you can reduce before you square. So I'm going to keep this 49 over 441 equals 84 over A. I'm going to keep this here to show you. Or you can reduce 7 over 21. They're both divisible by 7. So you could divide by 7 before squaring. So 7 divided by 7 is 1. 21 divided by 7 is 3. All we did was reduce. Now you would square, same thing. It's just being multiplied times itself. So 1 times 1 is 1, and 3 times 3 is 9. So I will show you that you get the same answer no matter what. Continuing with this, 1 times A is A, and 9 times 84 is 756. You do need to make sure you say meters squared or squared meters. And then over here, same idea. It's just your numbers are gonna get bigger. You're gonna multiply 441 by 84, which is a large number. 37,044. Divide by 49. Divide by 49, and we get the same answer, 756 units squared. Okay, this is where our video stops. I do ask that part of your grade for doing this flipped classroom is completing the last 2 questions. You have similar figures. One of them you're given perimeter, and one of them you're given area. So use the perspective formulas, fill in what you have, look for what you're missing, and bring it tomorrow.